Right guys, let's do the first one then. It's differential in this section. It's going to be quotients. Here's the booklet we need for this section. When we differentiate a quotient of the form u over v, where u and v are both standard derivatives or can be worked out as subproblems, then we use this formula here. It's v du dx minus u dv dx over v squared. You can see, I hope, that it does matter which way around it is, because there's a minus here. So there's not symmetry like there was with the product rule. So we can't just choose u and v arbitrarily. It's u over v. It has to be in that order, and it has to be v du dx minus u dv dx all over v squared, that way around. Okay, so let's just draw a template and follow our nose then. So u is equal to the top, v is equal to the bottom. Yeah, so we'll draw our grid like so. U equals x, v equals ln x du dx. It only takes a moment to fill this grid in. And the nice thing about this grid, the v dx log differentiates to 1 over x. Yeah. Nice thing about this grid is it minimizes the likelihood of making mistakes, as well as gives you method marks if you do happen to make a mistake. So then divide dx, so we can just read off the components then. V du dx. Notice I put a line across the page because it visually gives me a memory jog, really. That times that. So v du dx, you can write log x times 1 if you want, or 1 times log x. It's the same thing, isn't it? Minus u dv dx, x times 1 over x there, all over v squared. And here we've got an object, so it's that object squared. Not to be confused, of course, with ln of x squared, which is an entirely different thing. Alright, this, if you put 3 in, for example, you get log of 3 squared, and that would come out in the calculator as a number. This, if you put 3 in here, it would be log of 3 squared, which would be log of 9. And you wouldn't get the same. These aren't the same sort of things, alright? So I just thought I ought to flag that up. So you'll see a lot of logs and stuff like that. Okay, so there's the solution. We can tidy it up now, can't we? That's the differentiation, so let's tidy it up then. Divide dx equals ln x. The x's cancel top and bottom, and the 1 remains, over ln x bracket squared. That's fine. That'll be fine for the answer. Okay, let's go on to the next one. And they're all the same as this, just a matter of putting in the grid. And I won't, as I say, I won't dilly-dally with the subsequent questions, because we can just proceed with this grid, put the pieces in, and simplify. All right then, let's go on to the next one.